ridiculous. Oh, gee. Okay, this is WebAssign 4.2 emotional EMF. Two parallel rails of negligible resistance are 13 centimeters apart and are connected by resistor resistance R3. The circuit also contains two metal rods having resistance R1 equals 13 ohms and R2 equals 15 ohms sliding on two rails. The rods are pulled away from resistor at constant speed, so V1 equals 4 meters per second and V2 equals 2 meters per second. Respectively, uniform magnetic field of magnitude B is equal to 0.01 Teslas is applied perpendicular to the plane of the rails to determine the current factor. Okay, so I already took the liberty of drawing on the diagram, and hopefully that shows up well enough to show the kind of circuit we're doing with. So this is called motional EMF, right? So we have EMF, but it's moving. So we can use Kirchhoff's rules here to develop a circuit and then determine, sorry, the current in R3. Okay, so Kirchhoff, I should hopefully remember that it's EMF is equal to IR, right? Boom. But we don't have an E, and we're looking for R. So, all right, now we're looking for I and R3. Sorry, so we're looking for I3. So we do have R. That was my bad. So initially, what we're gonna do actually is we're gonna, instead of do E equals R, we're gonna do E equals VLV. And now this will give us our EMF because we have velocity, we have field, and we have our length. We have our length. Yeah. Sorry. Okay, so E will be equal to our field 0.01, right? Yeah, 0.01 Teslas times our length, which was described up here as being 13 centimeters, so 0.13 meters. And then now this respective velocity, I put V1 here. This will be V2 over here. Now this will be the same formula over there as well. So this velocity is 4 meters per second. Now this one is 2 meters per second over here. I'm not going to write the whole equation over again. It'll just be half of what we get for E1. So this is E2. So then E1 equals, let me choose a different color here so it doesn't all blend in. E1 is 0.052 volts. And E2, well, half the speed, same as everything else is the same, so it's just half of that, so it's 0.0026. We can start using Kirchhoff's, and we can start developing a circuit. So I'm gonna start with E1. E1 minus R1, I1. We're gonna start here, and we're gonna go down. R1, I1. That's an R. Minus. Now, when I say R3 here, the current is breaking off into two different directions. This is actually R3 and I1 minus I2 equals 0. That should make sense. Now, E2. E2, we're going to start with I2 and R2. So E2 minus I2 and R2, because we're on this side now. Like this half of the R2, I2. Plus, because we're going against the designated current, we have an I3, R3 plus R3, I1 minus I2 equals 0. And because we have values for these EMFs, we can actually, we can start solving. So what I'm going to do here is 0.052 volts is equal to 17 ohms. I believe 17 is R2 unless I got that wrong. 2 ohms, I1 minus 5 ohms, I2. Our other equation would then be 0.0026V is equal to 10 ohms I2 minus 5 I1. When we combine these, we get point. You can draw this in your calculator, whatever. And then you get I1 is equal to 0.0038, that's 0 times 10 negative 30 amps. And then using our equations above and just plugging back in I1, we'll get I2 is equal to 0.00252 times 10 negative 30 amps. Okay, and then using our junction, I believe, I1 minus I2 has to equal I3, so then we can just plug in those values we already had. And then we get an I3 value of 132. So this is a combination of a couple of, I don't want to say things, but a couple of building blocks. So the BOV equation, which is, I believe that's new to us for EMF, taking into account the velocity of the moving current, and then Kirchhoff making a circuit. And at this point, we're not, like with Kirchhoff, we're not concerned with the movement of the circuit. But does that make sense? Because we don't care about lengths in Kirchhoff, or at least right now I don't care about lengths. We just care about the current going through it and what resistance and what resistors the current will hit to hinder the flow of the current. So yeah, like I said, you have to start off with your BOV to get the EMF, which I don't think is something we've done in the past. Usually we have an EMF value, or we're looking for the EMF value for given resistance and current. But we didn't have current, all we gave them resistance, and we're given velocity, which is a different beast entirely to start solving these, because it's not something we're used to, or the components we're used to at least. Personally, the initial part, E equals BOV, in my opinion, that was the most difficult for me. I'm pretty confident in my Kirchhoff abilities and just plug stuff into Kirchhoff. But again, the combination of the two separate things is something we haven't seen, and it's just one of those things you gotta break into pieces, do one step at a time, and then all of a sudden you've solved it.